Welcome to the deep dive. Today we're getting into something that is absolutely critical for anyone serious about AI. We're talking MLOs, machine learning operations.
It's really the make or break discipline, isn't it? It's what decides if your cool AI project stays in a lab notebook or actually becomes a living, breathing, profitable part of a business.
Exactly. It manages the whole life cycle
It's
from,
big.
the first idea all the way to deployment and then keeping it alive.
Right. And that's our goal today.
Our mission isn't just to list a bunch of definitions, it's to get into the real mission of MLOps. Why is it so vital now? We're going to cover risk, people, process, and the big one, scale.
And we have to start by clearing up the biggest myth right out of the gate.
Oh, I know this one.
MLOps is not, and I mean not, just DevOps for machine learning.
Right. I hear that all the time. But let's break that down. I mean, functionally, isn't it just about packaging up a model? What makes it so different, so, exponentially more complex?
It's the asset itself. In traditional software, your code is pretty static. You deploy version 1 and it stays version 1.
Until you patch it, sure.
But an ML model isn't just code. It's this combination of code and the constantly changing data it sees in the wild.
Ah, so it's the data drift, the instability.
Exactly. The environment is inherently unstable. Your inputs change, your model's performance degrades, sometimes really, really fast.
And that dynamic, that relationship between the code and the data is why MLOps isn't just a nice to have anymore.
Not at all. We're past the pilot phase. Companies are going from one model in production to, well, tens, hundreds, even thousands.
And if you try to do that without a real MLOps discipline,
You're asking for trouble, massive continuity issues, quality goes out the window, and, well, you start seeing a real negative impact on the bottom line.
so let's unpack that scaling challenge because it's not just a technical problem, is it? It's deeply organizational. It's a people problem.
Oh, absolutely. The first hurdle is just shifting dependencies. The business needs change constantly. The data you're getting shifts.
And the model has to keep up with the original goal. It's a moving target.
It really is. And second, there's a huge language barrier that MLOps is trying to solve.
Right. You've got your business experts, your SMEs.
Then you have the data scientists and then the IT and DevOps team. They all live in different worlds, different tools, different priorities.
They're not even speaking the same language.
Yeah.
The scientist is chasing accuracy. The engineer wants uptime.
And the business just wants to see revenue. It's a communication breakdown waiting to happen.
Which leads right into that third hurdle you mentioned, the skill gap.
Yeah. Your data scientists are brilliant modelers, but they're not necessarily software engineers. They don't always know CI/CD best practices.
So they get stretched thin. They're trying to manually babysit these models.
Models they might not have even built themselves because people leave. Teams change. It's a real struggle.
And if we look at those other roles, the non-data scientists, their needs are so specific. Take the subject matter experts. They don't care about a model's F1 score.
Not the slightest. They need a simple, scalable way to give feedback. A button they can press when a model's result just doesn't look right in the real world.
They need context.
Precisely. They need to see the model's performance translated into something they understand, like profit or customer churn.
And on the other side of that, you have the auditors, the model risk managers.
Their world is all about compliance, governance, minimizing catastrophic loss.
So for them, MLOps has to be the system of record.
It has to be. They need automated, bulletproof reporting on every single model, past and present, data lineage, performance history. Every change needs to be tracked. MLOps is that accountability layer.
Which brings us to the core of it all. MLOps is fundamentally a risk mitigation discipline.
It is. And the sources all point to the same two metrics for assessing risk: the probability of something bad happening.
And the impact if it does, that classic 5x5 risk matrix.
That matrix just changes the whole conversation.
Yeah.
You stop talking about abstract accuracy and start talking about financial impact.
Let's make that concrete. So a monthly recommendation engine for, I don't know, a niche marketing campaign.
Low stakes. If it messes up, the impact is pretty small. You fix it next month.
But then you have a major travel site, and its entire revenue, its real-time pricing, depends on a single ML model.
Now you're in the red zone.
Mm.
If that model fails, the impact isn't just major, it could be catastrophic.
So MLOps forces you to build your process around the dollar cost of failure.
Exactly. And those failures fall into four main buckets. The model just isn't available, it's giving bad predictions, its accuracy or fairness is degrading, or you lose the key people who know how to keep it running. MLOps has to prevent all four.
Okay, so that's the risk MLOps is built to mitigate, but that all starts with the foundation, right? Let's get into the first step, Model development.
Right. And before you even write a line of code, the biggest, most arduous part is often just finding and preparing the data.
That's where all the time goes.
So much time. Once you have the data, you start feature engineering. That's the process of turning all that raw, messy stuff into clean, numerical features the model can actually use.
And that's not a small job.
It can be 60 to 80% of the entire project, just data cleansing.
Which is where something like a feature store comes in, isn't it? To stop reinventing the wheel.
Absolutely. Feature stores are becoming a core MLO's tool because they let you centralize and reuse that work. If one data scientist spends weeks cleaning up customer data, the next one shouldn't have to start from scratch.
It saves time, but it also creates consistency.
Which is the perfect lead-in to the next crucial part of development, reproducibility. If you can't reproduce a model's results, you can't audit it, and you definitely can't scale it safely.
So what does that require practically?
It's like digital forensics. You have to version control everything, not just the code, the hyperparameters, the exact training data set, and the entire software environment.
You mean down to the specific library versions?
Down to the specific build of Python. If an auditor shows up and asks what the model was doing on a Tuesday 3 years ago, MLOps needs to be able to recreate that exact state.
And that level of tracking is what even makes responsible AI possible. It can't just be bolted on at the end.
It has to be baked in from the start. And responsible AI really has two pillars. First is intentionality. Is the model aligned with its purpose? Is it explainable? Is it using unbiased sources?
And the second?
Accountability. Is the governance strong enough to actually prove it?
Let's stick with intentionality for a second, specifically that bias challenge. We've all heard the famous Amazon recruitment model example.
A perfect case study.
Yeah.
Because it shows that just removing the protected attributes like gender wasn't nearly enough.
The model just found proxies.
Exactly. It learned that certain words or phrases or even which schools people went to were proxies for gender. And it just kept on discriminating. MLOps needs tools to find those hidden proxies.
But it gets even more complicated. The sources bring up this ethical conflict between different legal definitions of fairness.
Oh, yeah. Like equal opportunity versus avoiding disparate impact.
Right. So ensuring an individual is hired regardless of their group versus ensuring that the overall hiring rate doesn't negatively affect one group over another.
And sometimes those two goals are mathematically mutually exclusive. You can't have both.
So what does MLOps do?
MLOps doesn't make the ethical call there. What it does is provide the metrics and the audit trail to show why a certain trade-off was made, who made it, and what the impact was. It provides the evidence for the decision.
Okay, so shifting from the lab into the real world, we're moving into the domain of the software engineer, the DevOps team. This is productionalization and deployment.
This is where CI/CD pipelines really come to the forefront.
But the CD part, continuous delivery, is different for ML. You're not just deploying an app, you're deploying what the source calls an ML artifact.
It's a great term. It's not just the final dish you serve. It's the whole recipe book, the list of ingredients, and a picture of the exact kitchen you cooked it in.
So the artifact isn't just the trained model.
Not at all. It's the model, the inference code, all the hyperparameters, the documentation, and critically, that exact specification of the software environment. Every library, every dependency. If you miss one piece, it breaks.
And that whole bundle gets fed into an automated testing pipeline. What kinds of tests are we talking about beyond the usual code checks?
Automation is everything. You need your base case test to check for obvious bugs. Then you need tests for weird stuff. What if a crazy outlier value shows up? Or a field is missing?
And you have to test on recent data, right?
Absolutely. Test it on data from last week's production traffic to make sure its performance hasn't already started to drift before it even goes live.
The goal here is always to minimize risk, minimize downtime. This is why containerization, things like Docker and Kubernetes, are so foundational.
They're essential. Models are finicky. They have very specific needs. A container is like putting each model in its own perfectly sealed, labeled, isolated box.
So Model A's problems can't crash Model B.
Exactly. And it enables these really smart, low-risk deployment strategies.
Like blue-green deployment. Can you explain that one simply?
Blue-green is about certainty. You have your current blue system running perfectly. Right next to it, you spin up the new green system, you test it, you validate it.
And only when you're 100% sure it's perfect.
You flip a switch, and all the traffic goes to green instantly. Almost zero downtime.
And a canary release is a bit more gradual.
Yeah, with a canary, you might send just 1% of your traffic to the new model. You watch it like a hawk. If it looks good, you slowly ramp it up to 5%, then 10, and so on.
And this is the key point, I think. Deployment is not the finish line. This is the big difference between MLOps and old school software.
It is so not the finish line. For ML, deployment is just the beginning of the real work. Continuous performance monitoring, the world changes, and so your model will too.
Okay, so that brings us to monitoring. The model is live. We know it's going to degrade over time. So the big question is, how do you know it's failing right now?
There are really two main ways to figure that out, and you need both.
The first is the gold standard, right? Ground truth evaluation.
Right. You compare the model's prediction to the actual correct answer. Did the customer actually churn? Was the transaction really fraud?
But the challenge there is delay. You might not know the ground truth for weeks or even months.
And that's a huge risk if the model is drifting fast. But there's an even more dangerous trap.
Which is?
Only checking the ground truth for the cases the model already flagged as suspicious. For example, only manually reviewing transactions the model said were probably fraud.
Oh, I see. You're creating a feedback loop. You're just reinforcing what the model already thinks it knows.
You're amplifying its flaws. You never learn about the new fraud patterns it's completely missing.
So you need an early warning system.
That's where input drift detection comes in. It's your complement to ground truth.
So if ground truth is about checking the answers, drift detection is about checking the questions themselves. It's monitoring the incoming data.
Exactly. You're basically asking, is the model seeing data that looks fundamentally different from what it was trained on? You're monitoring the statistical properties of the incoming data, the mean, the distribution, the correlations.
And if those start to diverge?
An alarm bell goes off. It tells you the model is operating outside its comfort zone long before you have the ground truth to prove its predictions are wrong.
And all of this relies on having the right infrastructure, logging everything, a model evaluation store to compare versions, online A/B testing.
And tying it all together, holding it all in place, is governance. It's the foundation of everything we've talked about.
And this isn't just a good idea anymore. It's being driven by real-world regulation.
In high-stakes industries, absolutely.
Hmm.
Things like GXP in pharma, which demands incredible traceability. Financial model risk management, where you have to have a rigorous inventory of every single model.
And then there's data privacy, GDPR, CCPA.
Huge impacts. They force you to have strict controls on data lineage.
Yeah.
You have to be able to prove where every piece of data came from.
But it's not just regulators, is it? It's public opinion, too.
For sure. After things like Cambridge Analytica, the public demands fairness and transparency. Companies have to manage that risk proactively now.
So the big takeaway here is that your level of governance has to be tied directly to the project criticality. You can't have a one-size-fits-all approach.
You absolutely cannot. The framework is clear. An ad hoc internal project. You can give the builder some autonomy, but that travel site pricing engine, an operational project that cannot fail, that demands a fully controlled, fully automated CI/CD pipeline and constant, rigorous monitoring. The risk dictates the process.
This has been a really comprehensive look at MLOps. It's just so clear that it's this necessary discipline that weaves together technology, people, process, and governance.
It is. The goal isn't just to get the highest possible accuracy score in a lab. It's about mitigating real-world risk and enabling scale in a sustainable way.
Right. It's about so much more than just the model.
And to leave you with a final, maybe provocative thought on that. Think about an industrial use case, like a consumption forecast for a power grid.
Super high stakes.
Extremely. Now, what happens when the prediction problem gets too complex? Say you're trying to forecast electricity use for individual households, which is incredibly random, very stochastic.
You'd think you'd just throw more complex ML at it.
You would think so. But sometimes the right answer is to actually revert, to simplify.
Revert, you mean go back to a less advanced method?
Yes. The system might stop trying to predict every house and instead aggregate the data. It might use a simple non-ML heuristic like a sharing key based on past usage.
Why on earth would you do that?
Because sometimes a simpler model that gives you a slightly lower score on paper, but is far more consistent, stable, and understandable in production, is the better business solution. It controls costs, and most importantly, it controls risk.
Wow, so the best score doesn't always equal the best model for the business. That's a fantastic point to end on. Thank you for joining us on this deep dive into the intersection of AI and real-world business discipline. We hope this gives you a framework for your next project.